Okay, and last but not least, we have our regression. So, regression essentially looks at the relationship between two variables, which are continuous, which essentially means that there are number values and they're not categories. Um, and they don't have kind of ordered ranks. So, for you guys, this will be Likert scales with 5 point value, 7 point values, um, other numerical things such as age. Um, yeah. And the big thing about regression is that you know that something is more kind of causal. So let's say, okay. So for example, for my second research question, I say that does age influence whether or not one wants to buy a product from a brand that uses sexual appeals? And we know that this is causal because age increases and essentially would have an effect on whether or not one wants to buy a product, and there can be no reverse of this. Because wants one wants to buy a product cannot affect how old you are. So if you have something like that, um, okay, for example, we have our attitudes towards the brand that uses sexual appeals and, actually wanting to buy a product from this brand. We don't know whether, or, it, yeah, I guess it's hard to make a case, whether or not one um, likes the brand, therefore they want to buy the product, or if one likes the product, therefore they like or dislike the brand. So if we have something in which we don't know that the relationship is causal, we'll use a correlation. And so to get to this, we'll go to analyze, and then to correlate, and then to bivariate. And so here you just throw in your variables. So again, like I was saying, would you buy the product? There isn't necessarily a structured order between whether or not somebody wants to buy the product and their attitudes towards the brand, or their attitudes towards the brand having an impact on whether they want to buy the product. Um, so anyway, so we throw this in as these two variables. We click OK, and we'll see the results. So here we see that there is significant results because the two-tailed test comes back as significant. P is below 0.05, and we have our Pearson correlation at 0.56R. So this is just kind of hypothetical. This isn't actually a part of any of my results. I was just kind of thinking of this now. So how we would report this would be something along the lines of there was a significant um, correlation between attitudes towards the brand and purchase intentions. And then we write in our correlation coefficient, which is R, we say equals 0.56. Oh, whoops, 56, and P equals, or P is less than 0.001. And then, of course, you would italicize this. But let's say that we actually have causal variables, which, according to our research question 2, we do. So we have age and um, and purchase intention, and we know that purchase intention can affect age because the more you want to buy a product does not make you younger. God, I wish that was the case. Otherwise, I'd be so youthful and not have these bags underneath my eyes. Anyways, okay, let's go to SPSS. And so we want to do a regression. So we go to analyze, and then we look down the list and we see regression, and we look for linear. So we click on linear. Let's reset this. So our independent is age because that is independent from um, anything influencing it. And then we also have would you buy the product as our dependent. We look at this is all nice, and we press OK, and then we get this fun output. So what we first do, we first actually have to look at the ANOVA, or essentially, does this um, does this actually fit a model? So um, when we see this ANOVA statistics, this tells us, okay, is how much is purchase intention explained by age? And we see that the p-value is above 0.05, meaning essentially that age does not yeah does not explain purchase intention. So we first have to report this. So we say, okay, to answer our second research question regarding regarding age and purchase intentions, a regression analysis was performed. Um, the results indicated that um, age does not does not explain um, purchase intention, and then we put in the F statistics values. Okay, so we have degree 1 and 242. So we look 1, 242. And this equals the F value, which is 0.07, and P equals 0.786. Italicize these. Does not explain. And then also on top of this, we look at our R squared, and essentially R square is the actual specific value in which age describes or explains, or the purchase intention, the fluctuation in purchase intention is explained by age. And so we look at here, and typically we look at either the R square or the adjusted R square. I think adjusted R square is more conservative. It's giving us a negative number, which it explains nothing. So yeah, because this is, yeah, we'll just look at the R square for now, and we'll say R square. So R2 equals, and then we'll highlight the 2 and go to this subscript or superscript R squared equals 0.00. That's really sad. And then, we see here that then we actually get into the regression coefficients here, and this tells us for which increase something is increased. So essentially, how old are you? So for one point that increases with age, so for each year that you're older, um, the purchase intention would technically increase by point zero, well, by nothing, by 0.004. Um, that's really sad. Anyways, sorry, I'm being very, very melodramatic. No, but sometimes, if you get insignificant results, it's like, oh, wah. But so for this, this is pretty much it. So for the regression, if there's no significant model, then essentially this is all you report. However, let's actually pretend that this was significant. Then we actually include the this stuff. So, yeah, essentially, okay, so let's pretend that this is significant and purchase intention is explained by age. Then we would also, in our results, include these coefficients, include the unstandardized coefficients. Um, yeah, so essentially what we would do, we would write da, 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 um, let's say like age is there is a relationship. There's a positive relationship between age and purchase intention. And then we put in our b values. So the unstandardized coefficient is b star equals. Okay, let's pretend this is a wonderful number that's not 0.004. So let's say 0.05. Um, and then the t statistics, which is which would be 0.27. Actually, I should probably follow this by the book and just report 0.00 yeah, 0. And then the p-value, which is 0.786. Sorry, I'm hitting pause sometimes just to make sure that this is in line with the methodology guidelines. And in this, it actually looks like they also would like to include the confidence intervals. So let me back this up and let's quickly rerun this regression again. And we'll go, sorry, so we'll go to analyze, regression, come on, linear, and then we go to, where is it? Is it under options, statistics? And we include confidence intervals. And it should be set at 95 and just leave it like that. Or if it's not set at 95, change it to 95. Continue. Okay. And then so you'll see, in addition to the statistics that we used to have, that the one that we had before, we also now have these two over here, which include our confidence interval. So lastly for this, if we have a model that fits, remember if if the model is not significant, there is no need to report these b values. But however, if this hypothetically speaking, if this is still significant, then we would also include after the c values or the p values that 95% confidence interval, and then in the brackets we put after writing this 95 CI, we put in the lower bound of our variable, how old are you, which is age. And so we say negative 0 to, in the bracket, negative 0 to 2.03. And there you have it, basically. So an increase in, this is hypothetically speaking, an increase in age yields an increase in purchase intentions. However, getting back to reality, this isn't actually right because the model is not significant. So wah, wah. Yeah, so there you have it. So this is pretty much the ins and outs of how to do all these basic tests. Yeah, if there's more or further tests that you'd like to do, or if there's some snags, if you're getting some troubles hitting something, then bring your questions for Thursday. We're going to answer them. It's going to be awesome. Yeah, that's my story. So I hope that you guys had a beautiful weekend. It was sunny and it was gorgeous. Yeah, I hope you guys have yeah, a beautiful rest of your week until Thursday. Okay, it's time for me to go. I'll see you later. Bye.